Example 1. Find the LCM and HCF of 8 and 12. Method 1. 8 can be written in prime factors as 2 times 2 times 2, which is equal to 2 to the power of 3. 12 can be written as 2 times 2 times 3, which we can write as 2 to the power 2 times 3. Therefore, we can find the HCF of these numbers. Recall, we look at the 2's. Since it says highest common factor, we'll pick the smallest 2, which is 2 to the power 2. 3 is not common, so we can't pick 3, meaning the HCF of these two numbers is 4. The LCM is equal to, we come to the 2's. Notice LCM simply means least common multiple. Surprisingly, these are not multiples, these are factors. So that's one area of discrepancy. Then we're looking for the least, but we look at the 2's. Of these 2, we pick the biggest 2. Notice we said the least, so we pick 2 to the power 3. Then we pick 3. Even though 3 is not common, we pick it. So that our own final result will be 24. That is method number 1. Method number 2. We want to write the prime factors of 8 and 12. 2 can divide this and obtain 4, 6. 2 divisors we have 2 and 3. There are no other divisors of these numbers without the remainder. So we stop there, which means the HCF is equal to this 2 times this 2, which is 4. We come to this other one. The prime factors of these numbers, after dividing through by 2, we'll boil down to the following. We have here 4, here 6, 2 goes here, we have 2, here we have 3. Here we have to keep on dividing until we have 1, 1 at the end. 2 divides this, we have 1. We leave this standing there. 3 also divides this, we have 1 and 1 here. In other words, our LCM is equal to this times this times this times is giving us 2 to the power 3 times 3, which is 24. Method 3. Method 3 decides to explain this better than methods 1 and 2. First of all, let us go to the HCF. Let P represent factors of 8, which is the set 1. 1 can divide 8. 2 can divide 8. 4 can divide 8. And 8 can divide itself. Those are the factors of 8. Let Q represent factors of 12. If we do so, we have 1 can divide 12, 2 can divide 12, 3 can divide 12, oh, I said 2 can divide 12, 3 can divide 12, 4 can divide 12, 6 can divide 12, 12 can divide itself. Now, when we come to this, we say to ourselves, what are the elements which are common to both 8 factors of 8 and factors of 12? These elements are 1 is one of them, 2 is another element that is common, 4 we have, that's all. Those are all the elements common to all of them. Then let us see what happens. P intersection Q, highest that is the highest factor in this set, is 4. As you can see, what is this 4? This 4 is nothing but the HCF. What does HCF stand for? H stands for highest. Common. The common factors of these numbers are 1, 2, 4. The highest amongst them is 4. Therefore, the HCF of 8 and 12 is actually 4. You can see between this method and this method, this other one has more merit. We come to the LCM, still on method 3. You can let A represent multiples of 8. And this will give us the following: 8, 16, 24, 32, 40, 48, etc. Let B represent multiples. Let B represent multiples of 12. B can be written as 12, 24, 36, 48, 60, 72, and so on. Then let us see what A intersection B will be. In other words, what elements are common to the multiples of 8 and multiples of 12? These elements are 24 is common there. You put 24. The next one is 48. The next one, you will see 72 here, but there's 48, there's 48 here. There will be 72 here if we continue. 78, 72, etc. And of these lots, please let's move on to this side. A intersection B, we are looking for the lists of these common elements. The list of them is 24. Again, you will discover that this method has more merit than the other two methods. And you will see how I am going to exploit this method in producing factors of expressions.